So, welcome to module 3.2. In the previous module 3.1, we have basically explained you the need for sequential circuits, why there is a necessity to remember something that has happened in the previous clock cycle. Now we are so we did explain the need, but we did not give you the circuitry which will basically ensure that the whatever is computed in the previous circle, previous clock cycle is basically remembered. So, what is the circuitry that can remember this, right? So, let me explain two basic elements that forms what we call as the sequential circuits, and they are latches and flip flops. Latches and flip flops can remember the values for across a clock cycle, for example, right. So, these are elements which can remember the bit values. A latch and a flip flop can remember one bit, right. And what is a latch, what is a flip flop, what is the difference, how can we construct them? These are some of the things that we will see in this particular module. First and foremost, we have seen two types of transistors, the N transistor and the P transistor. The N transistor is shown here, we have explained it very earlier in this course itself. Now, there is for all these transistors there is a gate, there is a source, there is a drain. Here also there is a gate, source and drain. When the gate is 0, the N transistor is cut off. When gate is 0, it is cut off. When gate is 1, it is connected. We say this is on and this is off. When gate is 0, the source is electrically disconnected from the drain, it becomes something like an open. When gate is 1, the source is connected to the drain. The P transistor works in the other way, that is when gate is 0, it is on, and gate is 1, it is off, opposite. Now, what we have done is we are designing now something called a transmission gate, where we have put a P transistor and N transistor back to back, as you see here, right. There is a P transistor, there is an N transistor connected back to back. They are connected here, and this is P and this is N, right. And this is the source and drain for both. These are the gates, and of course, I give some input here and I collect an output there. So, I connect the signal enable here and the signal enable bar here, right. So, when enable is 0, please note that this N transistor is cut off. Since enable is 0, enable bar is 1, so this P transistor is also cut off. So, when enable is 0, the in is electrically disconnected from out. When enable is 1, what happens? When enable is 1, enable bar becomes 0, this N transistor is on, also the P transistor is on. Now, in is connected to out when enable is 1. Interestingly, the P transistor, if you give a 1 on the source, it will give you a strong 1 on the output. So, P transistor is a good carrier of 1, while N transistor is a good carrier of 0, and it is a weak, N transistor is a weak carrier of 1, while P transistor is a weak carrier of 0, right. So, when both the transistors are on, by enable is 1, enable bar is 0, so P is on and N is on. When I give a 0 at the input, the N transistor will make it a good 0, though the P transistor makes it a weak 0, good plus weak will be good. So, I get a good 0 as output. Similarly, when in is 1, the P transistor will make it as a good 1, N will make it as a weak 1, good plus weak is again good. So, I get a strong 1. So, this transmission gate will take, when the enable is 1, it will take a 0 and produce a strong 0, it will take in a 1 and it can produce a strong 1. right. So, this is how the transmission gate works, and importantly when the enable is 0, the in and out are electrically disconnected. So, that is the most important aspect of the transmission gate. Now, with this transmission gate we will tell you how a latch is constructed. What is a latch and how is it constructed? Now, note that this is a TG transmission gate, this is also a transmission gate, this is the enable and these are inverters and this is a clock, right. Now, this circuit that you are seeing is called a latch, right, and what is a latch? Latch is 1. So, let us see the clock, how does the clock work? So, let the clock go from, so this is how the clock goes. So, we may say that this is tick and tock, tick tock, tick tock. So, this is actually the terminology we will be using in our thing. So, how does this latch work? So, let me say that we will just see this. So, this is the clock and this is the input. So, let me say that the input became 1 here, and so on, okay, right. Now, let me just draw also the basic where this is the clock pulse, right. And so on. Okay. Now, let us see how the output is going to behave. Please note that when the clock is 0, this TG is on. When the clock is 1, this TG is on, right, because this is connected. When the clock is 0, this not of 0 is 1. So, clock 0 means this TG is on, clock 1 means this TG is on, and vice versa. When clock is 1, this TG is off, clock is 0, this is off. When this TG is on, whatever comes from the input will, when this TG is on, when that is when the clock is 0, this is on, this thing is off, right. When the clock is 0, this TG is on while this is off. So, this circuit will look like an inverter with an inverter, and this is the output, right. So, this TG is on while this TG is off, right, because this now this is on means in is connected to the out. So, this looks like a short and it comes here and output. So, whatever I give as an input will get, this will become in bar and again in. So, out equal to in. So, when clock is equal to 0, out equal to in, and this out equal to in will happen till clock is 0. When the clock becomes 1, what will happen? When the clock becomes 1, when the clock becomes 1, note that this is 0. So, when the clock becomes 1, this gets cut off, while this TG gets cut off, whichever I have marked here, and this TG, the second TG actually gets on. So, when the clock becomes 1, it is something like, the circuit is something like a feedback circuit, because this is a short, the Tg that I am showing in red here is a short when clock is equal to 1, well this. So, what happens is, just before the clock became 0, clock became 1, just before the clock became 1, whatever was the value that would have been at this place, that out should be equal to that in. So, when the clock actually becomes 1, then that value in will be fed here, this will become in bar, that again in bar is in. So, this will be a stable loop, right. So, in bar in bar in bar in, right. So, when the clock becomes 1, what will happen? Whatever was there just before it became 1 will be retained, and it will be going in circles in this particular circuit, as I am showing in black here, right. It will be just going in circle. Again when the clock becomes 0, then what will happen? When the clock again becomes 0, this will become on, this will actually become off, and then the fresh in value will start, out will become in. So, let us look at this. So, now how will out behave? Let us see this. Now, so the clock is 0. So, when the clock is 0, so this is enabled, when the clock is 0, this is enabled. So, this will behave, out will behave exactly like in when the clock is 0, out will behave exactly like in when the clock is 0. When the clock becomes 1, when the clock becomes 1, right, so this will remain the same thing. Okay. Let us take this. Okay, let input like this. So, when the clock is 0, the out will behave exactly like in. When the clock is 1, it will retain the value. Now, the clock is 0 here again, the clock becomes 0 here. So, out will just behave like this. Now, the clock actually became 1. So, this will be like this. Now, when the clock is 0 here again, so this will come like this, right. Now, the clock became 1 here, note that this will be like this. Now, here please note that here in is 1, but that will not be reflected on the out, because when clock is 1, the previous value will be retained, right. When the clock is 0, whatever is happening on the in will come to the out, but when the clock is 1, whatever just happened before the clock became 1, that is what will be retained. So, you will be seeing a 0 here, right, and again the clock becomes 0. So, this will go up, you will see all these things, and then this will remain. Now, the clock is 1, so it will go till this. Now, the clock becomes 0, it will fall here and then it will remain. Okay. So, you see a change in behavior at this part as I have marked in orange, and also in this part as we are marked again in orange. So, now this is an element, the latch is an element which will retain the value for half a clock cycle, right. So, the clock cycle is between one full cycle is between one, we call it as a positive edge, that is going from 0 to 1 is a positive edge, 1 to 0 is a negative edge, positive edge of the clock or passage, and this is negative edge of the clock. So, one cycle of the clock is between one positive edge and another positive edge. So, how does this particular latch behave? Between when the clock is 0, input follows output. When the clock is 1, whatever was there before it became 1, whatever the input was there before it became 1, that value it remembers. So, half the clock cycle this changes and half the clock cycle it remembers. So, this is one element which can remember a value over a period of time, right. So, this is a memory element. So, this element, whether it is remembering or not remembering, that is dependent on the level of the clock. Level equal to 0, it actually follows the input, and level equal to 1, it remembers the input. So, the latch is triggered, meaning it starts accepting new inputs only when level is 0. So, this is called a negative latch. Negative latch means it is enabled when level is 0 and it remembers when level equal to 1. So, latch is a level triggered storage element. It depending on the level, it either remembers or it follows the input, right. So, this is what we call as a latch, which is a level triggered element, and the latch is basically built using inverter and transmission gates, right. Now, let us go to the next part of this, what we call as the flip flop. So, this what we are going to see is called a data flip flop or DFF. Okay. Now, how does this flip flop look? If you carefully look at this, there is one latch, the latch that we have seen in the previous slide, and there is another latch. One latch is feeding another latch, right. The left one is called the master latch, while the right one is called the slave latch, right. Now, master latch, the first transmission gate here gets the inverted clock. The second transmission, let me call it as TG1, TG2, let me call it as TG3 and TG4. TG1 gets the negation of the clock, while TG2 gets the clock itself, while on the other slave latch TG3 gets the, TG3 is the counterpart of TG1 in the slave latch, but it gets the positive clock, the clock directly, while TG4 gets the negation, right. So, when master is triggered, master latch is triggered, slave will remember, while the master remembers, slave will be triggered, right. So, when master slave, they work exactly in the opposite. When master is triggered, slave will remember, and when slave is triggered, master will remember. Right. So, this is very clear. Now, let us take, so this is the clock pulse. So, let us mark this area, this is, let us say this is the this is 0 of the clock. When 0 of the clock, the master is triggered, slave is remembering. At the 1 of the clock, the master is remembering, slave is triggered. Again at the 0 of the clock, master is triggered while slave is remembering, and so on. So, what will happen is when the clock is 0, whatever is there on the input it will come as in bar here. So, when the clock is 0, whatever is given as the input, that will come as in bar, and when the clock is 0, note that this is cut off, this Tg3 is cut off. So, slave latch will be remembering something. We will come to that, what is that something, very shortly. Now, when the clock is 0, in comes here, it is in bar, and of course, this is going to be in again, right. Now, when clock becomes 1, please note that when clock actually becomes 1, now this gets Tg1 gets cut off, right, while Tg3 is on, Tg4 gets cut off, Tg2 is on, right, when clock becomes 1. Now, this what was just before clock becoming 1, the value just before clock becoming 1, that will that let us call it in, that in bar will be here as you see here, and that in bar will become in through this NOT gate which I am marking in green, again through Tg2 it will come, and that will be remembered. So, what will the master latch remember, as that we have just shown in the previous slide, just before the clock becoming 1, whatever was there in the input, that will be remembered by the master latch, right, and the negation of that in bar will be fetched to the slave latch, right, and what will be the output of this slave latch, this is the output. So, this in bar will flow here, so the out will be equal to in, right. Okay. So, when the clock actually becomes 1, then what was there just before the clock becoming 1 in this input in, as I am marking in green here, will now come out here, right. Now, when the clock actually becomes 0 again, that value will be remembered by this slave latch, right, because when the clock becomes 0, this becomes on, Tg4 is on, Tg3 is off, the latch remembers that value. So, that out, that in is basically remembered here. The most important thing is when the clock actually becomes 1, when the clock actually becomes 1, note that this is cut off and this is on. When the clock is becoming 1, whatever is happening on the input will not come inside, right. So, this master latch is basically not transmitting whatever is happening on the input. So, whatever just happened before clock becoming to 1, that is what is here. So, when the clock is actually 1, whatever is happening on the input will never come to the output. Whenever the clock is 0, whatever is happening on the master latch will not affect the slave latch. So, this essentially, so please understand. So, when the clock is 1, when the clock is 0, whatever is happening on the master latch, the slave latch is not affected. Slave only will remember what happened before. When the clock becomes 1, whatever is happening on the input will not even go inside the master latch. So, the master only will remember what happened before the clock became 1. So, what will essentially reach the slave? Whatever was the value in the input just before clock becoming 0, that is the value which will go to the slave, and that value will be remembered till the next passage, right. So, the slave will remember what is the in value between this passage and this passage. Suppose before this passage the in value was 0 just before this passage, during the entire duration of this clock cycle between this passage and this passage, the slave will remember, slave will have the value, the output whatever we are seeing here, this output will have the value 0. Intermediately between this edge and this edge, if your input changes or something happened on your input like this, nothing will basically go to the output. The output will remain 0. So, just before the positive edge of the clock, whatever is the input, that will basically get reflected as an output, correct. And in between the in between in any of those period between the two positive edges, as we are seeing here, if there is any change in your input, that will not get reflected at the output. So, this is how a flip flop works. Note that the output of the flip flop changes on the based on the value of the input at the positive edge of the clock. So, this flip flop is called an edge triggered storage element, right. So, this is an edge triggered storage element. So, this has the capability of remembering the value between two positive edges. So, and this is basically constructed using two latches, one is a master latch and the slave latch, wherein a latch is a level triggered element, which we explained earlier. So, as a part of this project, the sequential element that we will be using is this D flip flop, that whose structure I have defined earlier, which is constructed using basic transistors. But like how you assume that the NAND gate, right, we assume that a NAND gate has been the basic element for combinational element, combinational circuit design that you have done as a part of your project 1 and project 2. Now, for this D flip flop, which is part of your project 3, now for the sequential circuit, which is part of your project 3, we will use D flip flop as a basic element. Right. So, D flip flop becomes a basic element. We will be using this D flip flop to do as a basic element to construct lot more of sequential circuits. Right. So, this is what we like to cover in this module 3.2 on latches and flip flops. So, to sum up, we have seen what is a transmission gate, we have seen what is a latch, we have now we also saw what is a flip flop, a D flip flop, and we also stated that we need not construct the D flip flop as a part of this project, but assume that the DFF is available, and based on this DFF we will go and construct many more circuits. Thank you.